Welcome to a new test and teardown video. This time it's a Philips function generator PM5132. And this one is a function generator from about 1980 and probably 10 years after that. Then they made newer models. The frequency range is very, very impressive. It goes all the way from 0.1 Hertz and to 2 megahertz. So look at that, 7 ranges. And I believe this is a variable capacitor. And there is supposed to be some sort of a stop here. But look, I can feel there is a little bit of a stop, but I can just go all the way around. So this is a little bit weird. I don't know if that is intentional or not. We got, of course, the different waveforms, sine and sawtooth and square wave, but we got a positive pulse and a negative pulse, and of course DC, where we can play with DC offset. And duty cycle, so if you enable duty cycle, you can change the duty cycle from 10 to 90%, and I bet that is only effective in the pulse modes. And of course output attenuators, and you can click all of these in if you like. Amplitude, all this with output impedance. And yes, there's also a sweep. So there's a sweeper in this. So now the sweeper is off, but we can change the sweep time from 1, 10, or 100 seconds. And so the sweeper, you have some outputs on the back where you have the sweep output, and you also have a pen lift. So the idea is you can use this to sweep your filters and use one of those XY plotters. So the sweep output drive the plotter and the pen lift, and then you can sweep all sorts of filters and fantastic things. You can start or the synchronization of your sweep here as well. So that's basically the fast presentation of this unit. It consists mainly of transistors and op amps, so there isn't really, I haven't really thought about it. This is all there is to say about it, transistors and op amps. And this is not good at all. This is the sine wave. Oh my. It is completely defect. This is not what I expected. So this is the... Why is it looking that bad? Okay, so what we see up here, that is the output frequency. You can see the shape of the waveform, but everything else here is some sort of an oscillation. Okay, so duty cycle is active in sine wave mode. Amplitude, oh, this potentiometer here is really bad. Oh, did you see that? And this is the output impedance and the attenuator. Aha! Attenuators! They affect the problem. So that tells me it is output amplifier oscillations. But look how unstable it is. Okay, and then we are back. That is interesting. And then it goes into these oscillations. Okay, I better have a look what is going on here. So this is the back of the unit, exactly what I said. Sweep trick input, and this is the sweep output you use to drive your plotter. TTL output, for scope triggering, obviously. and a pin lift output. I also see some interesting name here, and in 1984, I guess. So probably this unit is from 1984. Oh, we got some cooling holes, and it is using about 17 watts. So that's probably why you have some air cooling holes and all that. What do you know? All the circuit boards, they're covered by some really weird I don't know what that is. Some funny dirty stuff. Look at that. How's that possible? There is something that is really interesting I would like to show you guys. So here's the mains transformer. Look at that line. So that means all the metal sheets, they are assembled here, but they're also here. So that tells me that we have exactly the same piece of metal here and the same piece of metal here. And then they just mount them in here, and done. So it's not every second like you normally see. So why the heck is that? I don't think I've ever seen this before in a transformer like this. So what is the idea? This is of course for voltage selection. In the manual it explains how to solder these and configure the different voltage ranges. You gotta love this little detail here. So this is the on-off switch. Don't you just love this little wire that goes this way? And the clickety-click is in here. So this is a dummy switch. I think this is made so they can also solder this into a circuit board and then have this part located somewhere else. Isn't that just cute? Ha! The power supply is a little bit special. So the two regulators you see here, it's a positive and a negative regulator, and they're variable using a fourth pin to adjust the output voltage, and you of course got those two trimmers. This unit runs at plus and minus 22 volts, and that of course needs to be nice and stable, so I want to double check that is okay. There's a little bridge rectifier right there, and it's almost a yes. I think it is just touching the two capacitors. So that is of course not an optimal layout. What you should have done is to put the bridge somewhere else, a little bit further away from the capacitors. You never want hot capacitors. That's just asking for lifetime reduction. Here is the output power amplifier, and maybe that is the one that is going into some oscillation problems. Remember what I said earlier about this unit is op amps and transistors, and that is what we got here. Tons of transistors and tons of op amps in here. And of course all the adjustment trimmers and whatnot. Yeah, I should show you the bottom side, or this is actually the top side. I don't know if you like that color of that circuit board. Something tells me it is running very warm in this area. This is of course the output amplifier, so I would expect this to run warm, but there's also some funny part here that's running warm. This is something I always want to investigate. And there's a classic thing about Philips units like this one, and that is the power supply lift. So those different solder points you see here, that will be the different power supply sections you just disable by removing the solder here. And then if there is a short in the power amplifier or in some other sections, you can disable those sections and then manually debug. So that's quite smart. So I've been hunting around in here and I've been cleaning the different switches and potentiometers, and that did help quite a lot. See, now this potentiometer here is nice and smooth. So all that is fine, but look, it's looking like it is in FM sweep mode, but it's not. All this is off. See? Sweep is off. Of course, if I turn on sweep, it's gonna go, see? But there's something like, something is affecting it. And I think this is a ripple. And this is output attenuator. If I remove the attenuator and crank down the output, you can see there's some noise or some self-oscillation problems. So it's definitely still there. And probably has something to do with power supply problems. But it is quite a high frequency. Other than that, the potentiometer for frequency setting, or let me show you a little bit better view of the output. And let me try and see. Can you see there's some, no, I think it's difficult to show. Yeah, here we go. We got some funny holes, glitches. It's supposed to be nice and smooth. But it is getting better and better the more I move this. This is not a variable capacitor, but a potentiometer. And it goes, click. I can feel it's probably you're not supposed to do that. Yeah. Right. I really love when my first idea is right. So I'm now in AC mode on the scope, all right? And here's the power supply. Let me see if I can show you guys this at the same time. But here's the output capacitor of the positive, see? And I am in 1 volt per division, and it's nice and fine, right? And here is the negative supply. And here we go. All the nastiness comes from the negative supply. Ha ha. So I will go and change the parts here just before we go and poke around with that voltage regulator. It is about 1.5 megahertz, almost 2 volts peak. That is some nasty stuff going on here. So let's just measure a little bit. I changed the 2 capacitors. If we look at the schematic for the power supply, you will see those 2 capacitors. They are 1 microfarad and I think it was 22 microfarad on the output. And I just changed both of them for the negative supply only, just for a start. Of course, I'm going to change the other 2 capacitors on the positive as well. But look at that. 1 volt per division, and it is silent. And I didn't touch anything on the generator, so what we can do is just enable the output. And I want to show you something funny. If I crank up the output, I don't know if you can you see? Yes, you can. There's a trick. This is the power supply, right? So output is visible on the power supply. So when it's trying to drive the output high, the voltage on the supply drops. So the 22 microfarad on the output is probably not good enough, or the regulation is not good enough or fast enough. But of course this unit can handle from 0.1 hertz to 2 megahertz. So adding a big capacitor is definitely not possible, because it should also work on 0.1 hertz. And then it will show up if I add a capacitor and make it nice in the kilohertz range, because that is definitely possible, of course. And now we're gonna get this little unstable. Is that okay? This, yes, you see what I'm touching now is the potentiometer here. That is just, yeah, see, we got some points. Yeah, here it is connected, and then some points where it is not so good. Here we go. This is exactly where it is, and I can find that point. So for this one to be a nice, great success in the future, this potentiometer needs to be changed. Oh no, it is completely broken, and it is a very, very special one. Oh no! So I changed all the capacitors in the power supply. Now it's really nice and stable. Of course, we got a few points where the frequency setting here is having a little bit of a problem. But I want to show you one last thing, and that is the sweep feature. And that is so amazing. Sweep off. Here's sweep off, okay? So now I am in sweep 1 second. So this is the speed of the sweep, all right? Here is the start frequency. And here is something I want to show you that is really funny. If I dial this to the right, okay, can you see what happens? I can go to the right some more. Well, we're gonna see what is going on, right? And then I go back to the middle where there's nothing. And then I can go to the left. And then it goes the other way around. So it inverts the signal, or the sweep. So here it goes slower and slower, right? And then restarts. And here it goes. It's amazing. So how the heck did they do that? And so here in the middle, I don't have anything, right? So you can automatically say how much you want and what way you want it to be. So that is really cool. And you can hit the, yes. So here you stopped your sweep, and now you can move the start position. See, you can see here it's faster and here it's slower, all right? Or here it is unaffected, here it's normal, right? And then you can go and get it started, and then it's doing its thing. We also have, here, you can change. So this is variable speed. So this is times 1. And then it goes faster, 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 faster. Okay. We can go 10 seconds, and then we can go faster, faster, faster. So I really like this. And there's a hold. And how are they doing that, by the way? Remember, this thing only consists of transistors and op-amps. There isn't any fancy smancy software or any processors or cool things in this unit. And they just hold this forever. Ha! Amazing! Okay, let's go out of sweep. Thank you. And then we go the different. Oh yeah, duty cycle. Look at that. Ooh, nice. Yeah, this potentiometer needs a little bit of cleaning. I didn't clean this one, but I should. Oh, that is bad. Square wave, of course, is. Oh yeah, so I talked about the pulses before, and this is not exactly what I thought. what it's doing is it's just removing, see, it's only the negative component of the signal that is removed. Now it's only a positive signal, and it's only a negative signal. So that's just what it is if you want to feed this into a TTL logic or some other kind of stuff, right? And then you can of course go to the DC offset here and then fine tune it to whatever you want. So yes, of course DC, and then you have DC output variable voltage for whatever you want. That is actually also a feature I use quite often with my signal generator. Yeah, but I will go and clean this potentiometer a lot, and it also works in sine wave. Oh, this is really bad, this. So let's try and play with the duty cycle potentiometer now. Is this just pure magic or what? And here is a little message from my sponsor, yada yada yada. No, I cannot just use this all the time. Contact 61. It is just pure magic, just saying. So that was all I wanted to say. Yeah, man. Thank you very much for watching, and bye bye.